Hi everyone and welcome. Today we're going to shrink down and explore the amazing, tiny world of the atom. I'm so excited to get started.
So, have you ever just stopped and looked around and really wondered, what is all this stuff made of? I mean, the chair you're sitting on, the air you're breathing, even you. It's a huge question, right? But believe it or not, the answer starts with something incredibly, unbelievably small. You guessed it, it all starts with the atom. The atom is the basic building block for everything. So here's our plan. By the end of our time together, you'll be able to identify the parts of an atom, use the periodic table to figure out its structure, and even understand what something called an isotope is. Ready? Let's jump in.
Okay, so if atoms are the building blocks, what are they made of? Well, we can zoom in even further. Let's meet the three tiny particles that are inside every single atom. These are called subatomic particles.
Here they are, our three key players. First, we have the proton. Protons have a positive charge. A great way to remember that is P for proton, P for positive. Easy. Next is the neutron, which is neutral. It has no charge at all. And finally, we've got the electron, which has a negative charge. Now, take a look at their mass. Protons and neutrons have a mass of about 1. They're kind of the heavyweights in the atom. But the electron? Whoa, look at that mass. It's so tiny, we pretty much say it's 0. That's going to be really important in just a minute.
So, where do all these particles hang out? Well, think of an atom like a little solar system. In the very center, packed tightly together, you have the heavy particles, the protons and the neutrons. We call this center the nucleus. And all those super lightweight electrons, they're zipping around the outside of the nucleus, kind of like planets orbiting the sun.
Now, here's a really important idea to lock in. Atoms, in their natural state, are neutral. So, what does that mean? It's all about balance. For every positive proton inside the nucleus, there's one negative electron flying around on the outside. All those pluses and minuses cancel each other out perfectly. And what do you get? A total charge of 0. Okay, so we know what's inside an atom. But how can we tell a gold atom from a helium atom? Well, every element has its own special ID card. It's one single number that tells you exactly what element you're looking at. And we call it the atomic number. And you know what? The definition is so simple. The atomic number is just the number of protons in the atom's nucleus. That's it. If you know how many protons there are, you know exactly which element it is. This is why the atomic number is like an element's fingerprint. Think about it. No two people have the same fingerprint, right? Well, no two different elements can have the same number of protons. If an atom has 6 protons, it's always carbon. If it has 8 protons, it's always oxygen. The number of protons defines the element. Period. And finding it is super easy. Just grab a periodic table and look at any element. See that whole number right there at the top? That's it. That's the atomic number. For example, look at sodium right here. Its symbol is Na. What's its atomic number? It's 11. So what does that tell us? It tells us that every sodium atom in the universe has exactly 11 protons. All right, time for a quick check-in. I want you to pause the video, find a periodic table, and tell me the number of protons for nitrogen and for sulfur. Go ahead and give it a shot. Okay, welcome back. How did you do? If you looked up nitrogen, you should have found that its atomic number is 7. That means it has 7 protons. For sulfur, the atomic number is 16, so it has 16 protons. If you got that right, you are doing an awesome job. Fantastic. So we know how to identify an atom. But what about an atom's mass, or its weight? Well, for that, we need to look at the heaviest part of the atom, that nucleus in the middle, and use something called the mass number. The mass number is pretty much exactly what it sounds like. It's the total number of particles that have mass in the nucleus. And which particles were those? The protons and the neutrons. So you just add them up. And remember, those electrons are so lightweight, we just ignore them completely for this. Now, this is really useful because it lets us figure out the number of neutrons, which can be a bit tricky. It's a simple little math problem. Step 1, you find the mass number. That's the total. Step 2, you find the atomic number. That's just the protons. And step 3, you just subtract. The total mass minus the protons leaves you with the neutrons. Scientists have a handy little shortcut for writing this all down. They put the big number, the mass number, which is 23, here on top. And the smaller number, the atomic number, which is 11, goes on the bottom. So just by looking at this, we have all the information we need. Let's try one out together right now. Here we've got phosphorus. The mass number on top is 31. The atomic number on the bottom is 15. So to find the neutrons, what do? That's right, we just subtract. Top number minus the bottom number. 31 minus 15 gives us 16. So phosphorus has 16 neutrons. See? Not so bad.
Okay, this next idea is super interesting. We already know that the number of protons can never change for an element because that's its fingerprint. But what about the neutrons? Can an element have a different number of neutrons? Yep, it can. And when that happens, we get what are called isotopes. You can think of them as different versions of the same element.
So here is the main idea for isotopes. They are atoms of the very same element, which means they must have the same number of protons. The only thing that's different about them is the number of neutrons they have. Let's look at a perfect example, chlorine. We have two common isotopes, chlorine-35 and chlorine-37. Now look closely. What's the same? They both have 17 protons. That's what makes them chlorine. But look at the neutrons. Chlorine-35 has 18 neutrons, but chlorine-37 has 20. That different number of neutrons changes their mass number, and that's what makes them different isotopes.
Okay, your turn to be the expert. Here are 3 different isotopes of carbon. Carbon-12, carbon-13, and carbon-14. I want you to pause the video and see if you can figure out the number of protons, neutrons, and electrons for each one. Give it a try.
All right, let's see how you did. First things first, they are all carbon, so their atomic number is 6. That means they all have 6 protons. And since they're neutral, they also all have 6 electrons. That part is easy, it doesn't change. The only thing that's different is the neutrons. Carbon-12 has 6, carbon-13 has 7, and carbon-14 has 8. If you got that, you've totally got this. Amazing work.
Wow, we have covered a lot today. Let's do a super quick recap of the most important things. Remember, atoms are made of positive protons, neutral neutrons, and negative electrons. The atomic number tells you the number of protons, and that's the element's unique ID. The mass number is just the protons and neutrons added together. And finally, isotopes are just atoms of the same element that have a different number of neutrons.
You've done such a fantastic job today learning all about the atom. Now, the best way to make all this stick is to practice. So for your next challenge, go find a periodic table, pick an element, any element, and see if you can figure out its protons, neutrons, and electrons. Thanks so much for joining me today, and keep learning with EduLauncher.